Welcome back, guys. Here for the again crystal structure, and in which we are looking for unit cell. Now, as the translation vectors we have seen in detail, that is the primitive and non-primitive translation vectors are there. Related with this translation vector, this unit cell is based on. Now, as far as the two-dimensional lattice is going to be concerned, in that case, we know that A and B are the two vectors. Now, here also, if you can see the two parts, that is to be as an this vector, that is to be this A1, and this is to be as an b1 is to be there. Now in this case we have already seen what exactly happens with the translation vector and how this giving you the primitive and the non-primitive cases to be there. Now here in this case, as far as the unit cell is to be going to be concerned, if these translation vectors forms a parallelogram, as far as I am talking about two-dimensional part only, when in the two-dimensional case or the two-dimensional lattice, if the translation vector forms a parallelogram, then such type of the lattice which is going to be cell is nothing but to be called your unit cell for that two-dimensional lattice. Now in the same case, as for now looking for the parallelogram, all of you are aware about that the parallelogram is to be what exactly it is giving you, like this one is to be the case where the parallel sides are going to be the parallel one, and they are having the equal length, as far as opposite angles are going to be equal. That is what the your parallelogram is to be there. This is what the case for the two-dimensional thing, what is shown here in this your diagram. But as far as the three-dimensional lattice is going to be concerned, in that case this parallelogram we need six. That is, whenever I can say three-dimensional case, then it is having a b c, three vectors are to be there, and that will give you, as far as the your three-dimensional lattice is going to be concerned, it gives you six surfaces, and six surfaces of parallelogram that will become to be as a parallelepiped in the three-dimensional. And when in the three-dimensional lattice your translation vector forms a parallelepiped, in that case that part or that unit is nothing but to be that cell is nothing but to be called your unit cell is to be there. As far as this your whatever be the unit cell is nothing but to be in simple way smallest small part of the your lattice is going to be concerned, and it going on repeated and continuously gives you or gives that solid or that crystal structure is to be there. This unit cell going to be continuously repeated and till the end, what exactly its continues to be there and repetition is to be there, it is nothing but to be a building block for that your called to be as a crystal structure or solid is to be there. This is all about basically means to be as an unit cell is to be there. As far as a little bit in detail, if we want to see exactly to be as an unit cell, so these unit cell are of two types, that is to be as an primitive and the non-primitive. As these primitive unit cells are going to be concerned, it is also again to be very much simple to understand what is mean by to be as an these primitive unit cells are to be there. I already told you that what exactly the translation vectors are bifurcated in two parts, that is the primitive translation vector and the non-primitive translation vector. In this case also, all if suppose wherever the parallelogram in the two-dimensional case, now we are discussing in the two-dimensional case, whenever or wherever or the three-dimensional lattice is to be there, in that case wherever the lattice points are exactly on the corners, if suppose the two-dimensional case is to be there, and on the parallelogram if all the points are exactly or the lattice points are exactly on the corners of the parallelogram, then we can say the such type of the your whatever be the unit cell is going to be there, that is your primitive unit cell. As far as the three-dimensional case is to be there, we know when the parallelepiped is going to be formed and all the points or the lattice points are, or the atoms we can say, exactly on the corners of that your um, particularly parallelepiped is to be there, and in that case that particularly known to be as an primitive unit cell is to be there. As far as these primitive unit cells are to be there, they all when are exactly lattice points are exactly on the your corners, and that time the effective number for such type of the unit cell or the primitive unit cell is going to be 1. But as far as the non-primitive unit cells are going to be concerned, when we are discussing about the non-primitive unit cell, the lattice points are not only on the corners of your parallelogram or parallelepiped, but also in the both two sides, exactly inside that cube or on the surfaces of that particular parallelepiped. So in this case, wherever the all lattice points lie at only or not only on the corner but also inside that parallelepiped or on the surface, or on the surface either inside or the on the surface also going to be on the corners, there will be the points should be there, but instead of that, addition to that, the points or the lattice points or the atoms should be on the surfaces or inside that your parallelepiped. So in that case, such type of the unit cell is nothing but to be called your non-primitive unit cell. And as far as the effective number is going to be concerned in such a cases, that is to be for the primitive unit cell, it is going to be 1, no doubt, as wherever the points are exactly on the corners, that time we are taking its effective number as a 1. So additional points whatever it may be, either inside that parallelepiped, if suppose 1 on the corner, one effective number, and plus 1 inside that parallelepiped, that will be 1 and 1, that is 2 is to be there. Means how many extra atoms or the points lie on the surface or inside that parallelepiped, according to that the number will be going to be greater. As far as non-primitive unit cells are going to be concerned, the points are not only exactly on the corners but also on the surface or inside that your cube or whatever be your parallelepiped is to be there. So that's why the effective number of the non-primitive unit cell, it is always that's why greater than 1 is to be there. So this is all about what is to be as an unit cell is going to be there. As far as the other parts are going to be concerned, means that is to be, if suppose we are discussing for this same structures, if you want to see this one is the two-dimensional diagram is to be there. If you look at this case where a b c d, this one is to be the um, parallelogram form, it is two-dimensional case is to be there. If you look at this particular unit cell, it is, if you look at this a b c d, all the points are exactly on the corner, no other point is either on the surface or anywhere is to be there. And that's why such type of the your cell or the unit cell is nothing but to be called primitive, and that's why it is the word given to be as n p is to be there. But as far as if you look at this e f g h, this one is to be there. If you look at this here np, here is 1 point is to be there. And that's why if you look at this particular case where this efg is to be there, efgh is to be there, here the points are not only exactly on the corners but exactly at the center of these points are to be there. In addition to the one another point is exactly at the surface of the center is to be there. That means the such type of the unit cell is called to be as a non-primitive, and due to that the such type of the notification, that is np, is non-primitive unit cell is to be there. Here is one another example, that is k l m n is to be there. If you look at, here are the small 2 points, this one and this one is to be there, sorry, this one. So these 2 points are already at this surface, and another back surface is to be there, and that's why if you look at this case where the KLMN, these particularly unit cell are having not only the points on the corners but also on the surfaces. So that's why the such type of the cell or the unit cell is nothing but to be called as a non-primitive unit cell. If you look at the all these case, this is one is the first one case where the all the points are exactly on the corners, and that's why the effective number for the such type of the ABCD primitive unit cell is going to be 1. As far as this EFG H, this non-primitive unit cell is going to be concerned, points are exactly on the corners also. There is one another point inside this center of this your plane is to be there, and that's why this type of the your non-primitive unit cell having the effective number, that is 2. As far as the third one KLMN, this one is going to be the non-primitive unit cell is concerned. Here in this case there are 2 points inside on the surfaces of the center. That means the such type of the your non-primitive unit cell is having the effective number, that is 3 is to be there. So in this case, the whatever be the unit cells are going to be there are 2 points. As far as the unit cell is going to be concerned, it is the smallest small part of that crystal structure or the solid is to be there, and that if it going to be continuous till the end of the material, that will form a one particular structure for that solids are to be there or the crystal lattice are to be there. And as far as the what type of the translation vector is to be there, that will also contribute into the your unit cell, and according to that your there are types are to be there, primitive unit cell and the non-primitive unit cells are to be there. So this is all about what exactly meaning to be as an primitive and the non-primitive unit cell in general are to be there. So here one another part where exactly as an primitive and the unit cell is to be there. There are some another scientists who found exactly the how to get these primitive unit cells in this case. If you look at this, here are the nearer connected, if the such type of these are the different one calculation for the your primitive unit cells are to be there. They connects lattice all the points nearby lattice points are to be there, nearer whatever the lattice points are to be there, they are connected to each other. In this case, if you look at this diagram is to be there, they all are connected in this case. Now again draw normals at the mid, and with this whatever the joint points are to be there, normals if you drawn at the middle, that is like this, then it will give you the such type of the primitive unit cell when it is going to be formed. It is the Wigner said cells are to be there, and who scientists who found this such type of the units primitive unit cells are to be there. And translation vector in such cases, it is nothing but to be a dot b cross c is to be there. This is one of the another example for the your primitive unit cells are to be there. So looking forward to be as an this as a unit cells are going to be concerned, the another part which is also very much important, that is called to be as an basis. In the simple way, if I want to find out the basis is very simple part to understand. It is nothing but to be a group of atoms are to be there. An atom or a group of atoms are nothing but to be called your basis is to be there. Already we know that what is mean by the space lattice is to be there, and it is nothing but to be imaginary points and infinite numbers of imaginary points, and um, as far as they are forming identical surroundings, and that lattice is going to be formed, the such type of the particular case where it is to be as in two-dimensional or three-dimensional, according to that the point or the space lattice are going to be there. Now already we have seen this part what exactly this space lattice in my previous lecture. You can see that part in detail. So this space lattice and the basis are very much important. As far as this space lattice and the basis will form exactly gives you the crystal structure. So whatever be the our unit, that is to be as an crystal structure is to be there. This is somehow giving you exactly whatever be your space lattice, whatever be your lattice, that will give you exactly a crystal structure is to be there. As far as the basis is to be there, the basis is placed on each lattice points, means that basis is suppose of 2 points, suppose the sorry the group of two atoms, suppose basis is made up of two atoms, then the it will lie when the I can say the space lattice plus basis, that means when the merging or plus is going to be there, in that case the whatever be the two atoms group, that will coincide or the lie on the exactly space lattice point at the center of the space lattice, and center of the your basis coincides with the lattice point, and that's what the crystal structure is going to be formed. Now in this case the number of as far as the number of bases are to be there, group of atoms either 1 2 3, there are thousands of examples, that is 1 to 1000 examples are there. That means groups of the atoms may be from 1 to 1000. There are number of possibilities of group of atoms are to be there, and that's what exactly it is having the large number, that is 1 to 1000 groups of atoms are there. But as far as the space lattice are going to be concerned, these are limited, these are only up to 14 space lattice are there. But still in the universe we found that there are number of crystal structures are available. Why it is to be there? Either we are having only 14 number of your space lattice are there, but we have the basis in the large number, and that's why either we have very less, that is 14 number of um, space lattice are there, but the merging factor, that is basis, are of 1000 types, and due to that these 14 plus different types of the 1000 groups will gives you number of crystal structures are there, and that is why this particular crystal structure we can see in the universe of different types. Again many times we can say that a group is always you need greater than one number of atom, that means to be there will not be a group of one atom is to be there. But still there is one example, that is called to be as in copper, it is called to be as in mono atomic crystal structure is to be there. Either it is having only group with the one atom, that is with the basis, it will give you particularly a crystal structure, and such type of the crystal structure is nothing but to be called your monoatomic crystal structures are there, because the basis contains only one atom in this case. This is what exactly meaning to be as an basis is to be there. As if you look at diagrammatic form for this case, if you look at this, this is what the exactly lattice is to be there, and in this lattice part these are the two-dimensional lattice part is given, and here it is going to be plus with the basis, or basis is having of the two atoms are to be there. Now if you look at this case, this point, center point, this lies on the exactly center of the basis of the center, two atoms group is to be there, and center of this basis group is to be sorry two atoms group is to be lie exactly on the your space lattice. And if you look at this output is going to be, this point is lie on this space lattice, this point is to be there, and due to that at the center it lies, and that's why it gives you likewise the crystal structure is to be there. This is what exactly the crystal structure is going to be formed, as the merging or the colliding with the lattice with the basis is to be there. This is how the your crystal structures are going to be formed. And as far as this unit cell and the basis part is going to be concerned, these are very important factor for the creating any giving any structure to the crystal lattice is going to be there, or the solid is to be there. So once again, thank you. Be at home and be safe. Before concluding, I am trying to update slowly whatever the accessories I am getting. Still, slowly I am updating. So bear with this, and definitely you will find the much more better um, lectures or the online videos definitely in the next part also. So till then, goodbye.